So then looking at how Dolphin flashcards are set up, so this is a screenshot of the Git repository, and you can see a few folders here like backend, docs, and frontend. The frontend folder has the frontend code. And so then inside the frontend folder, we have the src folder, pronounced source, and the source folder has the actual code for the frontend. And so then within this, we've got a few folders. So first of all, we've got animations. So that stores a code for handling animations. So for example, when you click a button, it briefly changes in size to show a fun animation. That code there is stored in the animations folder. Then we've got the API folder, which has functions that allow you to fetch data from the API. And then we've got the classes folder, which is just some random classes that don't fit anywhere else. Which a class is kind of a piece of code. It's a bit like a function, but a bit different. And then components are components, and we've seen what a component is. And the ones in the components folder don't include any other components. So for example, the text we looked at in the previous example of React code, the header text would count as a component. It would go in the components folder because it doesn't include any other components. But containers stores all the components that includes another component. So for example, if you have a pop-up, for example, if you create a pop-up that pops up when you're logging out to say, do you really want to log out? Well, that probably has text in. It's probably got header saying, do you want to log out? It's probably going to have a button saying yes, or another button saying no. So then that pop-up is including multiple other components, which is why it has to be in the containers folder, because containers store every single component, which includes another component. Then we've got the hooks folder, which is a special type of function which is used by components, and we don't need to look into it in more detail now. And then we've got the strings folder, and the strings folder stores the data for overall pages. So for example, like the sign-in page or like the dashboard page, which we saw earlier. And then finally, the static folder stores two things. So it stores the CSS files that define how code looks, the color of buttons and that sort of thing. And it also stores the icons. And so then the components page, the components folder and the container folder are similar in terms of their structure, because there's another folder within that for each component. So for example, we've got a folder called the account dropdown folder, which is the down arrow that you can click to show the sign out button when you're on Dolphin flashcards. We've got the blob component, which is a blob that shows in the background of Dolphin flashcards when you load it. We've got the button, which stores the code for what a button looks like and how it works. We've got things like the ghost button or an image or that sort of thing. So these are all components. And then within every single folder, so for example, looking at the account dropdown folder, we've got a few more files. So we've got the main code, the main JSX file for that component, which is called accountdropdown.js. And then we've got this CSS file for that, and the CSS file then defines all the styles for the colors and that sort of thing. And then we've got the index.js file, which just allows us to import it elsewhere. So the main file here is just the account dropdown.js file, which defines what the component is and what does it do and that sort of thing. And the CSS file just defines how it looks. And then here you can see the screens folder. So each page or each screen is a component, which then includes multiple components, and then that in turn making each component can include multiple components. So the front end is built up of components that include other components that include other components, and so that's kind of how React works. So then the next section is a more practical section, getting started. How do I actually start coding? And before we start, if you don't know React, it might be best to pause the video here and then watch some YouTube videos explaining it in more detail before starting the section, because this is a more practical section of how you do things in practice. And so it's your choice kind of how you do it from here. And again, this video is just for reference, so you can stop it, you can start it, you can go back, and you can go forward whenever you want. And we use Git to manage versions of code and GitHub to actually store the code. And so Git is kind of the code that does version management, and GitHub is what allows us to actually store it somewhere. It's a server that allows us to have the code stored somewhere. And so looking at Git, a lot of the next slides are going to be from a Harvard lecture. So Harvard put all the lectures online for you to freely watch and freely use. And so it's a good idea if you ever want to learn how to do something like how do I use Git or how do I use Python or HTML, to just check if Harvard have a course about it, because they do very simple but very informative courses. So the next section then is from the Harvard course. And the reason we use Git is because it helps us to keep track of changes made to code. So for example, let's say we create a file and we're defining a few variables here, and we say variable A equals 1, variable B equals 2, and variable C equals 3. So we've added code to this file. Then let's say we add a new line to the code and we say, okay, variable D equals 4. And then let's say then we remove another line and we say variable B, we remove the line that says variable B equals 2. There's a problem now because we can't get to the previous version of code. Maybe you can do Control Z, but if you've closed the computer down, then you've lost any previous version of code. So if you make a change, if you mess code up, then you can't get to the previous version, which is a problem. And this is what Git helps you with by allowing you to roll back different versions and see different versions and that sort of thing. And another thing with Git is it allows you to synchronize code between different people. So here we've got a computer on the left, we've got a computer on the right, and we've got the server, and the server stores the actual code. And right now the server is storing some code that says B equals 2 and C equals 3. And so we can get that code and we can have it in each of our computers. But then what happens if we make a change? So for example, the computer on the left has made a change and it said, okay, A equals 1. And then the computer on the right says, okay, I'm making a change and it says D equals 4. So now we've got 3 versions of code. We've got the version on the computer on the left, the version on the computer on the right, and we've got the version which is actually on the server, which just says B equals 2 and C equals 3, which is in the middle. And so there's a question, well, which one is the right version? Which version of code is the correct version? And this is what Git helps you with. Because how Git works is you can push your code to the server, and so the server stores the most up-to-date version of the code. So now the server not only stores B equals 2 and C equals 3, but it stores A equals 1 and it stores D equals 4. So now we know, okay, the version of code on the server is the correct version. That's all good, but the computer still have the wrong version of code. The computer on the left doesn't have what variable D is, and the computer on the right doesn't say what variable A is. So each computer still has the wrong version of code. So how do we fix this? Well, Git also helps with this because we can then pull the code from the server and we can get the latest version of the code from the server, as you can see here. So now all of the computers, both computers, store what variable A, what variable B, what variable C, and what variable D are. So they all store kind of the correct and the latest version of code from the server, and then the server stores the kind of official thing of what the kind of correct version of code is, and the computers have taken that from the server. Another advantage of Git is it allows us to test changes to code without losing the original. So for example, let's say we've got this file here and we're going to make a change and we're going to say D equals 4. But if we make this change, we don't know if the code is broken, whether we've done something that's broken the code. And so we can test it and we can make a change. And then if we realize there's a problem with the code, then that's fine. We can just go back to the original version of the file. But if we say, okay, yes, the code is working, then we can push it to the official code, which is stored in the server, which you can see here. So we can test changes to code while still keeping track of the original version. And that's another key advantage with Git. We can also revert back to an older version of code. So for example, here we're creating a file, we're adding a line, and then we're removing the line again. So we add the line B equals 2, but then, we add the line D equals 4, and then we remove the line B equals 2 by accident. And so if we've removed a line, we can't get that back. If we've saved it, if we turn off our computer and we turn it on again, we can't do Control Z, we've lost that forever. But using Git helps us with this because we can just simply revert to the oldest version where we've got all the variables defined, nothing's broken, we haven't broken anything by deleting the variable B equals 2. And so we can revert back to old version of code if there's a problem. This is another key advantage of Git. And so then I've mentioned this, but GitHub then is a website that allows us to store code somewhere. It's the server and the website where we store code, but then Git is the code that allows us to actually keep track of versions and that sort of thing. So GitHub is running on a computer, and it allows us to push the code to GitHub, and GitHub is kind of where the code is actually stored. So if you think about it, GitHub is kind of the destination of where we want to get code, and Git is the code, or is the program that we use to actually get our code to the website. And so how we actually, let's say we're starting development with a new computer, and we don't have the code on the computer, how do we actually get the code on a computer? Well, the answer is the git clone command. So here we've got the server in the top right, and we've got a local computer on the bottom left, and we want to know how do we get the latest version of code on our computer. Well, we use git clone. We type it into the computer, and we say the URL we want, the kind of website that we want to get the code from, and where the code is. We type in git clone, and then we add the URL, and then the server will give us the latest version of code, and we can make changes to that, and we can do what we want. So the first steps then, once you're developing for Dolphin Flashcards, is first of all to install Git, to type in the command git clone and then the URL for Git, which you can see here. And again, this will be in the description of the video. And then you can make changes to the code. And to make changes, you need to install React, which you can follow the guide you can see here. And so then, looking at how to run the code in practice, the first step is to open the terminal. And this is what my terminal looks like because I'm using Linux. But if you're using Windows, you'll probably, once you've installed Git, you'll probably need to search for Git Bash, which is a program which is installed when you install Git. And so it'll look slightly different if you're using Git Bash, but it'll look similar. And the first step is to actually go to the file path you want to go to. So cd means change directory, and it's saying, okay, can you change my directory to the file path I'm going to type now? And so the file path here, for example, is development/python/dolphin flashcard app, which will be different to you because you've got a different computer and different file paths. But I can help you with this in more detail once you actually get to doing this. But you first of all go to the repository for Dolphin Flashcards once we've cloned it. So the first step, of course, is to clone it. The next step is to go to that repository in the terminal, go to that folder. And note when I say repository, I mean a folder, and they're kind of the same thing. A directory is another word I might use for a repository or a server, and they're kind of the same thing. Once we've gone to that, we then need to go to the front end folder, which is in the Dolphin Flashcard app, and it stores all the front end code. And then we need to install all the packages, and we need to be able to run the front end. So React is built on another technology called Node.js, which is a kind of a programming environment on top of JavaScript. You don't need to worry about that, but this is why we say npm install, because npm is a package manager for Node.js that allows us to install packages. So npm install just says install all the required files we need for Dolphin Flashcards. Once we've typed in npm install, we then type in npm run, and the website will load in your web browser, so the Dolphin Flashcards website will load. Then you can make changes to the code, you save it, and the page will reload automatically, so you can see your changes happen in real time. And whenever you sign in, you need to add the access link to the end of the URL. And you can see this here where it says the normal URL equals ID token equals some other stuff. So when you go to Dolphin Flashcards, you've got the normal URL in the address bar. You then need to copy and paste this access token, which I'll put in the video description, and you paste it at the end of the normal URL. And so what this allows us to do is it allows us to make the alpha a closed version, so only specific people can access it, which is the point of a closed alpha. And at some point when we release the beta version, then we will remove the access links so anyone can access it, so you won't have to do this anymore. But for now, to sign in, you'll have to use this access link, which you can see here in more detail. And so again, I'll put it in the description, but basically what you do is you copy this and you add it to the top of the address bar, you press enter, and then to reload the page, and then you can sign in properly. If you try to sign in without giving this access link, it will give you an error. And so then you can make changes, you can change the code and files, and then you save the files and you can see the website change in real time. And so then to change files, to make changes, you can use any text editor you want. You can even use Notepad, for example, but I would recommend, or at least I prefer, using Visual Studio Code. You can download it here, and I'll put a link in the description again for Visual Studio Code. And then we next need to look at more about Git, because we've got the question, once we've made a change, how do we put it on GitHub? And what do we need to know to do that? And so what we'll be looking at now is a few commands. So we'll be looking at the git add commands, the git commit and git push commands, which are the three main commands you need to use to make changes, to put your code that you've made on your computer on the server on GitHub. And then we also will look at how branches work, because branching is also a key thing that we need to look at. So first of all, then, the git add command. So let's say then we've got this file and we've made a change. So we've added a new variable and we've got said e equals 5, where on our local computer we've made the change, but it's not on the server yet. What we need to do is we need to type in git add, and then we need to type in the name of the file we've changed, and we do it here. And so then what this means is we've added it to kind of the list of the files we want to put on the server. We haven't put it on the server yet, but we've added it to the list of the files we want to put on the server. And then you can see it will give us a message kind of like this, where it will say what files we've modified, like this. So once we've added the files, we then need to commit the files. So we need to say, yes, I definitely want to add these files to the server, and I definitely want to put these changes on the server. So the way we do this is we type in git commit -m and we type in the message. So the first step is to do git add, then the next step is to do git commit. And so you can see this here where we've done git commit -m and we've given a little message of what we've done. And so then we're adding it to kind of we're committing the list, and we're sort of like saving the list. We're saying, okay, this is definitely the changes I want to put on the server. And then this is a screenshot of GitHub, and it shows all the commits that I've made to Dolphin Flashcards with all the commit messages. So if you kind of remember what a commit is, it's where we save this version of code that we're looking at the moment, and we say, yes, I definitely want to put this on GitHub. If we make any more changes, we need to add them and then commit them before they can be included. So if we make a change and we do git add and git commit, then if we make another change, we can push the code to Git and to GitHub without kind of changing what version of code we have. So I'll say that again because I didn't explain it well. So let's say we've got a file and we've on the server it says a equals 2, and then we clone that repository and we make a change. We say b equals 2, and then we do git add and we do git commit, and so now those changes b equals 2 are committed. If we then delete all the code, then if we do git push, then it will upload the changes where it will upload b equals 2, but it won't upload the deleted code. So it won't delete everything on the server, because to do that we need to do git add first, and we need to do git commit first. So what I'm trying to say in a roundabout way is that every time you make a change, to make it go on the server, you first need to do git add and git commit. That's basically the summary. I've kind of not explained it that well, but that's kind of the summary of what I mean. Then once we've committed everything and once we've added everything, we then need to actually push it on the server. So in this example, we've committed the change and we've said we've added e equals 5, and we've got the commit message of add line. We then type in git push and it goes to the server. And so you've got a new commit on the server, you've got the original code, and you've got a new commit when you've added the line. And so each commit is essentially a different version of code. And if you go back in previous commits, you can see the version of code changing and changing. And so that is basically what a commit is. It's a snapshot of what the code looks like at a certain point in time. And then finally, we need to look at git pull, because the problem is, let's say then we go to the server and another computer makes a change. Another computer clones a repository, they delete a line, so they delete the line that says b equals 2, and then they do git add and git commit and git push, and they put it on the server again. So now on our local computer, we've got an old version of code, because we don't have the line that says b equals 2, we don't have that line deleted. So how do we get the latest version of code from the server? Well, we can use a git pull command. So what we do is we type in git pull, and then it will load that latest commit for us, the latest snapshot of code, where it's got the line b equals 2 deleted. And so then that's what the git pull does. It pulls the changes from the server, which is the correct official version of code, and it pulls it onto our local computer. Next, we need to look at making changes and how commits work. So again, a commit is a snapshot of the code at a certain time point. So let's say we make a commit and we make our first commit, and then we make some changes and we make some more changes. Then let's say we begin working on a new feature, and the feature is a really long feature and it takes a long time to work on. So we do one commit, and we've added some more things, but we haven't finished it, and so we do some more changes and we add another commit, and we still haven't finished it. But then we've got a problem, because what if you suddenly realize the code has a problem and it's got a bug in it and you need to fix the bug? But the issue is you need to finish the code isn't working at the moment because the feature is still in progress, and so you need to finish the feature before you can finish a bug. So then it takes time to fix the bug, because not only do you have to solve the bug, you also have to solve the current feature. You also have to finish the current feature you're working on. So that's a problem. So then what we can use to fix this is something called branching. So with branching, we first add our first commit, we make some changes and we make some more changes. But then instead of just adding the new commit and adding the new commit for our new feature to the main branch, we add it to another branch, to another version of the code. And you can think of each branch as another kind of version of the code, essentially. And so we start the new feature on a new branch, and we keep working on the new feature. So then at this point, if we realize, wait a second, there's a bug we've got, we don't need to finish the feature, this current feature first to solve the bug. We can simply get the latest kind of stable version of the code, and we can just fix the bug. So the latest stable version of the code is the version in the main branch, where before we started working on the new feature, and we're fixing the bug and we're adding that commit to the main branch. And so then the way you can describe this is as a master and a feature branch. The master branch is the main branch, and it's got all the latest commits that you're working on. It's got the stable commits. So this code in the main branch is working, but the code in the feature branch isn't working. It's still in progress. And so when we fix a bug, we don't add it to the feature branch, because we need to finish the feature first to be able to add more changes, otherwise the code won't work. Instead, we're going to add it to the master branch, where we've got the latest working version of the code. So the master branch, the master version of the code, has the latest working code, and the feature branch, the kind of the latest in progress version of the code, where the code is in progress and it's maybe not quite working. That's called the feature branch. And so then we also call the master branch the head branch, which just means kind of like the main branch. And then once we've then made all the changes, once we finish working on the new feature, we merge that feature branch to the main branch, to the master branch. So now the master branch has the latest feature, and because the latest feature is finished, that's why we can merge it to the master branch. And so now the master branch still has a working version of code, and so it always has a working version of code. And then another thing to talk about is forks, because if you're going to Dolphin Flashcards and if you're changing things, you can make a feature branch or change things, and you should. But another thing you can do is forking it, where you basically, it's kind of like you download the Dolphin Flashcard repository and then you upload it in your own account, and so you've got your own version of Dolphin Flashcard yourself. So then you can make whatever changes you want, you can do anything you want, and you can mess around with branches, and it won't do anything to my or to the main kind of version, the main repository of Dolphin Flashcards, because you've got your own separate repository. But then once you've made all the changes, you can say, okay, I'd like to take this branch of my repository and I'd like to merge it with the main Dolphin Flashcards repository. So you can merge the two together once you've finished a feature. But the fact that it's a different repository means that you're even more free to make changes, because if you completely break the code, that's fine, because you haven't affected my repository or the main kind of repository for Dolphin Flashcards at all. And so this is allows you to be a lot more comfortable about the changes you're making, where instead of just creating a new branch and testing on that, you can create an entirely new fork of the repository. You create your own clone of the repository, and then you can edit that yourself and you can merge back when you're ready. And so a pull request is basically what happens when you merge something. So if you're making a change in a feature branch and then you want to merge with the main branch, you create a pull request, which is a little message that goes to me because I'm the maintainer of Dolphin Flashcards. And it's there, and you say, it's got a little bit of text which you describe what you've done. You say, can I merge into the main branch of Dolphin Flashcards? And then I would approve it, hopefully. And then it would go into the main version. So it adds a bit more security where instead of just merging it when you're ready, you can merge it when you're ready, but you need to get approval first, which is a good way to get feedback on code. And so then we merge it when we're kind of finished, and before you merge it, you first create a merge request, and then once that's approved, then it is merged automatically. So how Dolphin Flashcards works is we don't quite have a main branch and then feature branches from that. We've got a development branch. So if you're making a change, you make a feature branch based on the development branch. So you go to the development branch and then you make a new change. You make all the changes, and then once you've finished the feature branch, and the feature branch is named after the specific feature you're developing. So, for example, login page or dashboard page. Once you finish that, you merge it back into the development branch. So the development branch has the latest version of code, which is sort of stable. It's not been fully checked, but it's probably going to be working. And the feature branch has the latest version of code, which is definitely not working because you're in the middle of adding features and you haven't finished it at all. And then you've also got the main branch. So when you want the changes on the development branch, when you want it to actually go on the server, you merge it into the main branch. And that's when all the checks are done and you definitely are sure it's working, because the main branch is what the code that's actually running on the server. So if you go to Dolphin Flashcards, all of that code is taken from the main branch. So the steps are: you make your feature on the feature branch, you merge it into the development branch, and then you merge the development branch. After a bit, you merge it into the main branch to actually get the codes to show and the changes you've made to show on the server. And so I usually merge the development to the main branch, and it's just kind of done whenever I feel like it would be good to get the latest code on the main branch. And so this basically allows us to have more checking. But that's how the kind of branching strategy works. Now, before you start a new feature then, let's say you've cloned Dolphin Flashcards, what do you do next? Well, you type in git switch development, and this allows us to go to the development branch, and then you do git fetch origin, which just gets all the latest branches and things, and then you do git pull origin development, which gets all the latest changes and all the latest commits since you cloned it, because if you've cloned it a few days ago, there might be more changes in the development branch which you haven't got. So that's why you need to do git pull. And once you do git pull, you need to create your own your new branch. And so you do git checkout -b and the new branch name. So you're creating your feature branch from the development branch. Then while you develop a feature, you should be committing and pushing your changes regularly. And the reason is because if your computer breaks or if there's some issue with something, then you need to make sure that your code is saved on the server. If it's not on the server, it's basically not saved. Where if you're writing a document, a report or an essay or something, if you haven't saved that document, then your writing could be just lost easily. And it's with code, if you haven't pushed it to the server, it's the same thing where if you haven't pushed it, then is it really there? It could easily be lost. And so you should regularly be pushing to GitHub. Like if you do half an hour or an hour of coding, at the end of that, you should really be pushing that to GitHub. And yeah, and with all of these commands, once you start using them, then you'll get better practice with them and you'll start to be better and better at using them, even if it's kind of difficult at first. So to then get your code and to put it on GitHub, you do git add dot, and dot means add every file that's been changed, and then you commit it. So you do git commit -m, and you say the change you made, and then you do git push, which pushes it to the branch you're working on, which should be the feature branch. And then once you finish the feature, there's a few steps you need to do. So you create a pull request on GitHub, and then you can ask me to merge it, and then I'll look at it and I'll approve it, then I'll merge it. And then you also need to update the backend/init.py file. And what this file is that basically it stores a version of code that the code is currently on. And so that means if there's a problem with another version of code, then you can revert to the last version of code, and you can see if that works. And so if there's a problem, you can have code that works without needing to fix the problem first. So it means you can sort of resolve problems faster, a lot faster than you would otherwise. You're still going to need to do a patch, and you're still going to need to push a fix to solve that, and then you can update to the latest version of code again. But it's kind of a way, even if it's not as good, of making sure changes don't stop the entire code from working, the entire website from working, if you mess something up. And so then you can see 3 numbers here. So it says 5.4.0. and the format is major.minor.patch. So the 5 is major, the 4 is minor, and the 0 is patch. And this follows something called semantic versioning. And what this means is the right-hand number, which is a 0, is known as the patch version. So you increase this by 1 if you're doing a really, really small bug fix, just something very, very minor. And then the middle number is known as a minor version, so it's the one you'll be doing most of the time, and you increase this number by 1 if you're doing a medium change. If it's not small enough to be a patch version, so if you're doing something fairly significant, but if it's not big enough to be a major version, and I'll talk about what a major version would be in a second. So that's then when you would do. So then finally, we've got the major version, and the major version is which is on the left-hand side, and it's number 5. And so you update the major version if you're doing something that could break the code. So for example, if you change how the API works, and if you change what you need to pass to it to get data, then that could potentially break the code, because if you're still expecting to use the old version of the API, then the code that you're using could suddenly stop working. And so that's why I use a major change to tell anyone using the code that something major has happened, and you need to look at the release notes to work out what's happened. And so each of these, when you make it that you've changed, you'll increase it by 1. So you'll increment it. So then once you finish a feature, you also need to make sure that the merge request is correct. So this is a screenshot of a merge request which somebody has requested for Dolphin Flashcards, and at the top you can see it says Zanny D&D wants to merge 12 commits into Jacob McLeod development from Zanny D&D change unit tests issue 165. So they've forked the main repository, and which is owned by Jacob McLeod, which is me, and they've created their own repository, the forked version of my repository called Zanny D&D. And so they've made all the changes they want to make. They don't need to worry about it messing up my code, or not my code, but the kind of main version of Dolphin Flashcards. And then they finished the version, and they've made sure it works, and then they want to merge it back into the main version of Dolphin Flashcards. And you can see they've made their own feature branch. So they've made a branch called Change Unit Tests issue 165. And they're asking to merge their feature branch into the main development branch for Dolphin Flashcards. And so then you can also see the kind of description of the unit tests. And if at the very top it says minor change unit tests issue 165. So that's a merge request title. And you'll notice it says minor at the top. So that's because when we look at the previous slide, so you could have a major change, you could have a minor change, or you could have a patch change. And so then this minor at the top says, okay, I've selected a minor change, and it could also say major, or it could also say patch, if you've updated the init.py file accordingly. And so the reason this says minor is because then once you make a merge request in the script, which checks you've done it correctly, and so this is kind of extra checking then, and it helps the script with checking that. So then you can see at the top you've got the description of the merge request, and then you've also got the pull requester checklist. So that's a checklist of everything you need to do before you merge to make sure you've done the correct things. And at the very bottom it says has changelog.md been updated to explain a new version. So changelog.md is a file which tracks all the changes made to code. So for example, you can see on line 25, it says the code for the changes for version 5.4.0. So it's added the ability to search for flashcards, and it's improved the documentation. And this is in Markdown, which is a kind of a programming format, a scripting format. And if you, on line 25, you can see there's 2 hashes before it starts the section. 2 hashes means I want to have a medium header. And then it's got 2 hashes, and then it's got the version number, so 5.4.0. And then it's got 2024-09-19, which is the date that version was done. And then on line 27 and on line 31, you can see there's 2 headers. They're small headers because they've got 3 hashes instead of 2 hashes, and the headers say added and changed. You could also say fixed and removed, which you can see in the comments above. And basically you just use whichever of them you feel is appropriate to describe the changes you've made. So if you've only added new stuff and you haven't changed anything, you haven't removed anything, you haven't fixed anything, that's fine. You can just say added. If you feel like you've removed something but you haven't done anything else, then that's fine. You can just say removed. It just helps with tracking the changes made. And then under the headers on line 26, 27 and 31, I've then added bullet points of the changes made. So when you make a change before you merge, you need to update this changelog.md just to record the change you made. And so then once you've finished a feature, the final thing you need to do is to remember to merge into the development branch. So if you remember on the diagram we had before, the latest version of code is in the development branch, or at least the latest sort of working version of the code. So the main branch stores the latest version of code that is definitely working. The development branch stores the latest version that is probably working, and the feature branches store the latest version of code that probably isn't working, or something's not quite finished. And so when you merge your feature branch into the development branch, you need to make sure you do it into the development branch, because that's the version of code that's probably working but does need more automated tests before we can definitely decide it's working and merge it into main. And you can just select that within GitHub. And when you begin to make a merge request, you can kind of see how to do it, and I can show you how to do it. So then that's just an overview of how to do it. So we've almost finished this then. So let's just look at some closing points. So in summary, we've looked at how React works, and while we haven't looked at it in detail, I've hopefully given you a starting point, which you can then use to kind of watch videos yourself, and I'll link videos in the description to kind of explain how to do it. And then we've also briefly looked at installing npm and React. npm allows you to install packages for React. And then I've also done a very quick overview of how Git works and how you can use it for Dolphin flashcards. If you don't feel like I've done a good job explaining it, then that's fine. And you can find loads and loads of YouTube videos on how Git works. And that's also true for anything else in kind of programming. If you don't know how to do something, you can just Google how to do it. You can watch a YouTube video. You can ask ChatGPT. There's loads and loads of ways to learn. And then we've also looked at how you develop features and what you need to do to make pull requests. So what are the next steps then? So the first step is to install React using the links that I'll send you, and then to install Visual Studio Code or another code editor of your choice. I would advise using some code editor and not something like Notepad, because then it can do syntax highlighting and some other fancy things, which is nicer to work with. It highlights it in fun colors and so on. And then the next step would be to watch a video on React and to kind of learn how to use it in practice. So I'll send you a link, and this is what will help you actually teach React in practice, because we're on a very kind of high level overview of how to use React, but we haven't looked at anything specific. And then once you've watched this, you can go a long way just by Googling things and asking ChatGPT questions when you've got questions. And so the next step then would be to install Git and clone Dolphin flashcards. And once you've completed the above things, then let me know and I'll send you your first task. So then, thank you for watching this. I know it's been a long kind of presentation, but hopefully it's been useful. Hopefully I've been able to explain things well. And if you've got any questions at all, then please do message me in Slack to clarify anything, or if you want any more information on anything, and I would be happy to answer. So yeah, thanks for watching this video.